Next, what we're going to do is we're going to set up and have a look at our gate rotor blades, our internal inspection of the gate rotors. Now remember I said before, you're going to collect a bunch of oil coming out of there. So I've removed some of the bolts. This is what I've used. Stick this under the compressor somehow of some sort because you want to collect this oil. Otherwise you're going to be cleaning it up off the floor and off the side of the machine. So collect it this way or collect it the other way with rags. You choose. And if this machine was just shut off in the last hour, you're going to have a lot more oil coming out. And if it's a larger machine, you'll have even more oil. The other thing I've done is I've taken the bolts out and I've put some just plain studs in here. And these are just bolts with the ends cut off, but they keep the housing or the cover from dropping. Okay, so I can take these bolts out, and as the bolts come out and you just kind of pull it away, the oil will run out the bottom. You can just let it collect until you're finished dripping, and then you can pull the cover right off. This is a 240 millimeter. It's not that big a machine. If we go up to our 401 millimeter machines, this cover is a lot heavier, and it actually even has a place where you can put an eye bolt on the top, so you may have to take it off with a lift. It's a lot heavier. So we'll pull this off. Now there's a gasket in there on refrigeration machines. If this was a high pressure machine for gas, it may be an O-ring. Okay. Gaskets are always changed. You don't reuse them. So we do on this test machine or our trainer. But what do we have in here? We have what we call a gate rotor assembly. This is part of the sealing of the main rotor. And so what we need to do is measure our axial movement of this, because we have two thrust bearings in the bottom here. We have a radial bearing at the top. Where did I use those terms? I used them for doing the main rotor as well. So we really have essentially a mini version of the main rotor setup in the gate rotor area. So we want to check how much movement there is up and down and how much radial movement there is in and out. Okay, and we can do that by setting up with, again, our dial indicators. I'll take this out. We can put this part in here, set it up on the side here. I may have to just put it over a little bit. Sometimes you have to fiddle around with this to get it sitting just right. So one of the things that we have to position this blade in the right position. Okay, we can't just measure it anywhere. So if we have one of the blades sticking straight out, that means on the back side it's kind of V'd. So it'd be on the back side, it would be sitting like this by the rotors. I want one of these in the center of a rotor. Okay, so that means I put on the outside here the V centered. Okay, and I can set up my dial indicator here like this. And now I have to measure how much movement I have going up and down on this support. This is called a gate rotor support. This is called a gate rotor blade. The support holds the gate rotor blade in position. So I'm going to get my blade out again. And I may need to put a little bolt in there. And you can see how I can lift up on this. And then I can check how much axial movement I have and I'm picking up nothing. So that's telling me I have no axial movement on these two bearings here, which is good. That's what I want. I want no more than 0.02 of an inch. If I haven't explained it before, there's a magnetic base here. You can switch it on and off, which allows you to move it around, and then you switch it over, and then it sticks. Okay? Now you have to kind of set this up. So I've got it set up on the face of the shaft there, and I'm going to try and get some movement out of it. Okay? I'm going to stick my fingers back in there. You can see how I'm moving at about 1/1000th of an inch. Okay. So that's telling me this radial bearing. I'm going to look on my chart again. Okay, gate rotor. It's called the axial float. We're not even showing the radial on that one. So it's within 0.02 of an inch. Okay, so we're good on that one. So it was actually less than 1. So we know the health of these bearings are good. Okay, we've got another one on the other side, but we're going to work with this side right now. I'm going to take this off. See, I took the magnet off. So we've measured, what did we measure? We measured axial, up and down, radial, in and out, or side to side. The bearings are good here.